The integral y times e to the 0.2y dy is a good candidate for integration by parts, and that's how we're going to evaluate this integral. We first need to identify a u and a dv, and I'm going to let u equal y and dv be the rest of the integrand. So u is equal to y, and generally we're going to want to pick, for the most part, y to be a polynomial if a polynomial factor exists. And then dv is equal to e, and it'd be easier if we express 0.2y as e to the 1/5 y dy. Since u is y, du is equal to dy. And when we anti-differentiate e, let's talk about how we would differentiate it. If I were to differentiate e to the 1/5 y, I would pick up a factor of 1/5 out front using the chain rule. Therefore, when we integrate, we're actually going to pick up a factor of the reciprocal. So v is going to be equal to 5e to the 1/5 y. With this in front of us, I'd like for you to go ahead and flesh out the integration by parts formula and see if you can find the answer to this integral. uv is 5y e to the 1/5 y minus the integral of v du is going to give us minus the integral of 5 times e to the 1/5 y dy. I'd like to point out something that is pretty important. Every piece of the original integrand, including the differential, has been accounted for over here with our u and dv substitutions. When we differentiated u, we wrote down that du is equal to dy. Sometimes people will say du is equal to 1. Yeah, well, it's 1 dy. And so we have that differential as well. When we anti-differentiate the dv, the differential we no longer write, right? Because we use that up when we anti-differentiate. When I flesh out my new integral, uv minus, the integral is actually the integral of v du. I'm using the du because I have to write a differential, right? Every single integral needs a differential. And so as long as we keep track of all of the pieces that we need to when making our substitutions and differentiating and anti-differentiating, and then putting it back together into the integral, then the math will all be clean. Now integrating 5e to the 1/5 y is going to give us another factor of 5. So our final answer is 5ye to the 1/5 y minus 25e to the 1/5 y plus c. This is often sometimes expressed as 5e to the 1/5 y factored out, right? So then that would be times the quantity of y minus 5 and then plus c. I don't personally care which one you give me. And if you wanted to, you could give the 1/5 y back as 0.2y the way it was given to us to begin with. In any case, it would be a good practice for you at this moment to check this by differentiating to make sure that it's what we started with. I'm going to move on. Recall that I said before in a previous video, never pick dv equals to the natural log of x dx. This is going to be our next example. We're going to integrate the natural log of x dx. And you'll see why I said that. We're going to identify u is equal to the natural log of x. And on first glance here, we say, well, we have natural log of x dx. There's nothing left for the dv. Well, yeah, remember the differential, right? So dv is equal to dx. Then if u is natural log of x, then du is 1 over x dx. And since dv is dx, we know that v is equal to x. Using the integration by parts formula, we're going to write down uv, but I'll write it down as x times the natural log of x, minus the integral of, now look, v du becomes simply dx, because 1 over x dx and multiplied by x, the x is all divided out. And we end up here with x times the natural log of x minus x plus c, and that's our answer. Now let's note, if we had picked u as 1 and dv as the natural log of x dx, then we'd be stuck with u equals 1, dv equals natural log of x dx. I'd want to anti-differentiate the natural log of x dx. Folks, this is exactly what we started with. We haven't helped our cause at all. So this is one reason I say never pick dv as the natural log of x dx.